I forgot to record. All right. So what's happening in this video is that Paul, Alpha's father, is going to be asking me math questions. So this guy did math competitions when he was younger, and he's trying to put me through that same weird stuff he was doing when he was younger. So let me try this out. Could you explain the question, or you want me to read it and figure it out?
Uh, no, you can read this one. I'll try to explain the other ones because the other ones are like harder. I feel like this one's pretty. It's like a warm up.
Okay. Alice and Bob are playing a turn-based game on a circular field surrounded by flowers. The circle represents the field, and there are X flowers in clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction between them. Wait, let me like draw this out a little bit. It's already annoying. Whenever it says Alice and Bob, I'm like, bro.
I'm gonna kind of move this. And I hate Google Meets, like the little thing that pops up.
Okay, Alice and Bob are in a turn-based game on a circular field surrounded by flowers. So it's some sort of circle like this, and we throw Alice right here. We'll throw Bob right here.
Okay.
Right. So there are X flowers in the clockwise direction. So X like X. So it's like see there's like random flowers in the clockwise direction, right? And then there's Y flowers in the anti-clockwise direction. So that's like somewhere between these. These are the Y, right?
Well, that would be clockwise. Are you talking from Alice or
Oh, sorry,
Bob?
sorry. Wait. There's X flowers in the clockwise direction between Alice and Bob, and Y in the anti-clockwise direction between them. What? So clockwise, pretend. Wait, let me see.
Yeah. I think what you're going for is right.
Yeah, okay. So anti-clockwise is so between Alice and Bob. If we're going clockwise, this there. If we're going anti-clockwise from Alice, we're going like this way, right? This is
Mhm.
anti-clockwise. Alice and Bob, we're going this way. So X shows. So that's what it's saying, right?
Yeah.
Damn, are you dazed and confused on this one too, or no?
No, no.
Okay, okay, okay. I need you to be able to explain it too, because this is some hard shit. Well, I don't know yet. The game
No,
proceeds as
this one's
follows.
easy.
Alice takes the first turn. In each turn, a player must either choose the clockwise or anti clockwise direction and pick one flower from that side. So Alice is going to take one from either side. At the end of the turn, if there are no flowers left at all, the current player captures their opponent and wins the game. Given two integers n and m, the task is to compute the number of possible pairs x and y that satisfy the condition. Holy crap. Why is it N and M, but then it says X and Y in here? But anyways.
Well, your X and Y is what their X and Y are not necessarily N and M. They're two different sets of numbers.
So we're given two integers N and M. The task is to compute the number of possible pairs X and Y that satisfy the condition. Alice must win the game according to the described rules. The number of flowers X in the clockwise direction must be in the range 1 to n. The number of flowers Y in the anti-clockwise direction must be between 1 and m. Return the number of possible pairs X and Y that satisfy the conditions mentioned in the statement. What? What the heck? Okay. This is so weird. Okay, let me think about this. Let me just let's work through the example.
All right.
So we're given input n and we're given input m. And chat, do not spoil it for me in the comments, please. in the chat. I don't want to cheat. So we're given. Let's see. Alice and Bob are playing a turn-based game on a circular field. By the circle represents field, and there are X flowers on the clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction. So I'm gonna remove these.
Okay.
Because now that we ironed that out, in each turn we start Alice. Alice must either choose the clockwise or anti-clockwise. Either looks on this side or this side and picks one direction and one flower from there.
Okay. Yeah.
And so they just start picking turns.
Yeah.
If there are no flowers left at all, the current player captures their current opponent. At the end of the turn, if there are no flowers at all, the current. So let's look at. So what are the following pairs? X and Y. So X is the clockwise direction. So the first one is like 1 and 2. Right? So Alice goes first. So Alice chooses this one obviously, and then Bob chooses this one, then Alice chooses this one, and since they're the last person to choose, they win.
Yep.
Alice wins, right?
Yeah. Well, no. Sorry. Could you repeat what you said? I think you might have had it confused there.
Wait, what do we return the number of possible X and Y pairs to satisfy the conditions mentioned? Well, okay, if Alice picks green.
Yeah.
If there are no wait. How do they win? If there are no flowers left at all. Okay. So Alice is gonna choose this one, right? He's gonna choose this. Bob is gonna choose this. And then Alice is gonna choose this. Since Alice was the last one to pick it, and after Alice picks, it became 0. Alice wins, right? That's why the pair 1 and 2 works. Because we just need to return all the times that Alice wins.
Okay. Yeah, I think you got it.
So honestly, we don't really care about. I'm trying to see. We don't really care about either side or the number on either side kind of thing. Because if this was 3, Alice would still win because Alice would pick this, Bob would pick this, and Alice would pick this and win, right?
Yeah, so how do we tell who wins?
Well, we can tell who wins based on like if it's odd or not, essentially. If it's odd, Alice is gonna win. If the number on each side, if you combine the numbers on each side, if it's odd, Alice wins.
Okay, sounds right.
So if we combine the number on each side and it's odd, then Alice wins. So what now we're just given N and M. We pretty much need to figure out the amount of combinations that we can make. Wait, what does N tell us? N tells us that that's how much flowers we can place on this side. So we can place 1, 2, 3. So N tells us we can put we can possibly put 1, 2, or 3, like anything under that, like 0 to this many, or no, 1 is just inclusive, 1 to N inclusive.
Yeah, it's 1 to N.
So yeah, we could put 1 to N here. And then for 2, we could put on this side that we can literally put 1 to 2 on this side, right? So it becomes a combination. Like given these. So one way to do it is. Like for every one of these ones, well, if we figure out how many, so for every odd number, so what we need to do is we just need to figure out based on these combinations. Let's just do some simple math here. Based on these combinations, 2 times 3, how many possible combinations is actually possible? Well, it's just 2 times 3. We could have 6 possible combinations here, right? We can have 1 and 3, or 1 and 1, 1 and 2, 1 and 3. Like 2 times 3 equals, but these are just all the combinations, right?
I wouldn't. Okay, I guess.
There's 6 possible combinations between that. We essentially, it's the result is going to be less than that.
Well, 6 would imply that you're able to use 0.
Wait.
Hey, never mind. Never mind. I guess you're kind of right here.
Yeah, so there's 6 combinations. Um, there's like 6 different pairs that you can create, but only some of them are like you need to add up to the even. So now I just need to figure out how do we quickly find based on these numbers. It could be let me think of a brute force solution, and then maybe you could optimize it to just like a single calculation. But we just need to see based on like n and m, like how many odd combinations between like the pairs we can create,
Yeah.
right? So let me see if I can, let me like write it out quickly so I can see. So like pretend this is 1. So we have 1, 1. So if we just have 1 here and we have 1, we could do 1, 1, 1, 2. Right? If we put 2 here on this side, we have 2, 1, 2, 2. If we have 3, like these are the possible combinations, right?
Yeah, that's right.
And then like if we add these up, we only need to care about the odd ones. So this is 1, 2, 1. This is odd. So this is even. This is even. This is odd. Right. So the result here is 3.
Yeah.
Okay, so now the main part I'm thinking is like how do we easily find out like how many odds we can create given that. So what we can do is maybe we can loop through 1. If we have 1, we could just figure out how many even numbers can be made out of this. And you could just do that by dividing by 2. So you could be like, for 1, how many even numbers can I make? I can make 1. And we do that and then for 2, how many even number or odd numbers I can make if I had 2? Well, I can make 1 if we just divide this by 2. Right? So we could just ask that question for every single element. We could be like, okay, if it's an even, how many odds are there in the like how many odds are there on the other side that I can make by taking like y and dividing that by 2, taking the floor.
Mm-hmm.
That'd be like a O-Venn solution if we take this smallest one. Does that make sense?
Yeah, that makes sense. I'm just wondering, do you need to necessarily, like, if you know the calc beforehand, does it need to be oven?
Yeah.
Like, if you know
Yeah,
exactly
yeah.
what
If you know
the
how much
baseline
evens
number.
are here, how many even numbers are here, it's like some weird calculation. Pretend I know how many evens. Basically, what you need to do is be able to calculate how many evens are here. Evens times odd, because that will produce an odd.
Yeah.
And then odds, how many odds times even? because that will produce the odds again. So that's on one side. And now I'm just wondering if we need to do it for the other way. I think just that will just solve it right there.
I think you're right.
Yeah, like you do even, you just calculate the even and you multiply it by how many odds there, and then if you just know how many odds, just calculate by how much evens, and from there you just that's the result.
So you're saying to add those two, or what are you saying?
Add those two, yeah, we have to add those two.
Okay. Yeah, because you had like an equal sign there. I was like, I don't know what the equal sign up there
Yeah,
is
yeah,
yet.
yeah. You have to add these two results.
Okay.
And then how do we calculate even? Well, we just pretend we just take 8. No, I mean we divide it by 2. We take an integer division. So it's between 1 and the thing, right? So we need to
Yeah.
minus 1. So
My bad.
this equals 4. Actually, this would, let's see, evens. This would equal 4 evens if we just divide it by 2. But actually, we just care about... We just care about 1, 2, 3. We just care about 2, 4, 6, 2, 4, 6, and 8. Okay, dividing it by that works. How do we keep track of how many evens there are? So if we do 8 divided by 2, this will get us evens between 1 to n. Now I just need to see how many, if it will calculate the odds correctly. So how many odds are there? Well, there's 1, 3, 5, 7. So there's 4. Does that work again? So I think you just divide it by 2. Like you just do this. Let's
I would.
work on 9.
Yeah, I was gonna ask, would that work on an odd number?
This will do 4, right?
Yeah.
Because we take the floor. So 9 divided by 4 equals 5. So if it's odd, we just need to plus 1. Plus 1.
Is there another way of doing that?
Take the ceiling. Yeah, we could just take the ceiling.
Yeah, it's a bit like, I don't know if I'm pretty sure Python. I don't actually think Python works this way, but like you could just integer divide it. Yeah, just anything like that works. Ceiling works too.
Yeah. So that's the solution. Let me go ahead and implement that.
Okay, sounds good.
Damn, 20 minutes for that? Holy crap. I'm cooked.
Python. Oh, okay. I didn't. I thought that was true alpha. I just wasn't sure. Yeah, because that's converts it to decimal by default.
What we'll do is evens. So like I mentioned, we're going to have... Let me see. Is this an easy question?
No, it's medium.
Oh, really?
It's like 1570 ELO or something. 1581.
Wait, how do I get back to the whiteboard? So, what we said we're just going to do evens times evens. Oh, even time odd. Odd times evens. So what we're going to do is we're going to calculate n evens. We're going to calculate n odds. Then we're going to calculate m evens. And then m odds. How we're going to do that is we're going to do like math.ceil. Ceil function. And then we're going to take n divided by 2. We're literally going to do this for all of them. So n. Wait, for evens. Oh no, for evens we just divide. For odds we
Yeah.
take the ceiling.
Yeah.
Right? And then we just literally return n evens times m odds plus the odds times stuff m evens like that. Then just run solution and but can I use the AI assist to just make sure I'm calling the ceiling properly?
You're doing it right.
Okay. N is not defined. Oh, so dim. One.
That's good.
Wait. 3, 2.
Seems you're getting the wrong thing.
Wait. So I take the evens and I multiply that by the odds. I take the number of evens and I multiply that by the odds. I take the number of odds and I multiply that by the evens. I'm just gonna quickly print this out.
Okay.
So pretend this is 9. Oh shoot! I did this in so good.
I was gonna tell you if you didn't catch it after a little bit, but you caught it. Yeah, that should work now.
Let's get it. Next one.
If you're curious, there is a one-liner. There's
But
just
just combine these, right?
m times n floor 2.
Oh my god, how does that work?
Well, because you're basically taking every combination of 1 to m, 1 to n. Let me just write it down here. Like 1 to n times 1 to n. And basically half of those will be an odd, comma, even because of the nature of like odds and evens being half of numbers. So half the combinations will be the same and half will be different. So you can just divide this by 2 and it gives you the same answer.
You're right. That's crazy.
Yeah, I don't think anyone would expect anyone to get that though.
Kind of makes sense if I like enumerated it out.
Yeah, like if you had more time to like think about it, you'd probably.
I was thinking more about it in the terms of like in the circle.
Yeah. No, like if you had more time, you could like if someone said, "Oh, there's a one-liner," you could probably get the one-liner.
Any feedback? How was that first approach?
That's pretty good. I don't think you were like slow. It's definitely like good for interview context. I think like, yeah, you were able to pick up the pattern pretty quickly in terms of just multiplying the evens times the odds plus the odds times the evens. And I think you probably would have figured out that it was O of 1 before I said it was O of 1. I just said that too early, I think. But I think you would have figured out you didn't need to do an O of N loop.
Nice. All right, let's get in that next one. That was just the warm up, right? Is it gonna get harder or similar? Because that was almost my maximum mathematical ability.
I'll go a little bit harder, and if you get this one, I'll go crazy just for fun. All right. So for this one, I'm just gonna go over the basics. You have 2 positive integers left and right, and you want to find 2 other integers, num1, num2, such that num1 is less than num2, and they're both between left and right inclusive. So these are like your left and right bounds, effectively, for the numbers. And both numbers are prime, so it's two distinct prime numbers within the range. Um, and then num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions.
All right.
So effectively what that means is you're finding the two pairs of primes within this range that are the closest together, like the two closest primes within this number range. And you want to return just both of the primes as an integer, num1, num2, or like as an integer array rather. And yeah, there can be multiple primes. Just return the smallest one. And if there are no pairs of primes, you just, like if say there's only one prime or no primes in a range, you just return -1, -1.
Okay. All right. Let me read over the question quickly. That was a really good explanation, but I'll have to read as well. Um, we're given left and right, so these are kind of the boundaries. So there's like 10, 19. Find two integers num1 and num2 such that num1 and num2 are not the same numbers and it's between this inclusive. So we're looking for any values within the number range of 1, 12,
Yeah,
13,
it is
13,
inclusive.
all the way up to 19, right?
Yeah.
It's like pretty much in this number range.
Yeah.
Then all we need to know is we need to find prime numbers between these. And both num1 and num2 are prime numbers. Num1 is a minimum amongst all other pairs satisfying the above condition. Return the one with the smallest num. If they're okay. So, I mean, one thing we could do is literally something like for I in range 1 or left inclusive to right +1 because that's going to include that boundary. What we're going to do is we can just calculate, we'll actually come up with the primes and push them into some sort of array. We'll be like, if I is prime, push it into the array, right? So this is the first loop. Essentially generate primes between left and right. Once we generate the primes, it's pretty simple, like two-pointer solution. Pretend we have like the different primes. Return one. This is the brute force. What are the primes here? 11 because what's a prime number? A prime number is divisible by itself and 1, right?
Yeah.
Prime equals divisible by itself and 1. So 11, 12, that's not prime. 13 is prime. 14 is not prime. 15, not prime because it's divisible by 5 as well. 16, not prime. 17 is prime. 18 is not prime. 19 is prime, right? These are the 4 prime numbers in here. I mean, these two have a distance, and since it's already sorted, we could just compare adjacent ones to see. Wait. Okay, since these are already adjacent, when we like if we just like compare each to the adjacent, we should be able to find the minimum. So this is 2. These are 4 apart, and these are 2 apart. So 11 and 13 is the smallest. So what we can do 2 passes. The first pass you just figure out what the smallest distance is, and the last part you just return on the first time you see something with that smallest distance. So that will lead to, if we were to generate this, that would lead to like a O n times how does Like, how much does it take to generate a prime? Like, how do you
So you're saying how much does it take to check if it's prime?
like what one thing we could do is like we can just generate the primes first. There's a
Mm-hmm.
we could just generate the primes and then only look at we could generate primes up to 19 and then like only look at the range between that and 19. How we would generate the primes, I mean there's multiple algorithms, and if we decide to go with the solution, I can talk about that. But I think that's my brute force solution, and it's going to be like the bottleneck is generating the primes.
Okay.
How
I
does that
think
solution sound?
I think that solution sounds good. I'm just interested in how you're going to generate the primes.
Let's see. One So, like one way we could do it is okay. What is a prime number? A prime number is any number that's divisible by one in itself, right?
Yeah.
So that means another way to look at it is that there isn't a smaller number that's a multiple of it. So for 25 is a multiple, like right. So
Yeah.
5 times 4 equals 20. So what we could do is we could initialize some sort of array of 1 to 19. So like 1, 2, 4, 5. And it could just be x's, right? Or falses. This is true right here, right? False. We
Mm.
could we could just initialize this something like this.
So is this like the prime
Yeah.
per?
Basically what I'll do is
So,
like for 2, right? So I'll just like set these to true because these aren't prime, because if we
oh,
do
so
true,
these are so you're marking true for prime and false for non-prime.
true or sorry, it'll be false. True means prime.
Okay. Okay. Yeah.
So true
And
means prime,
and
right? So this is so okay, we'll start everything off as a prime. Shit. So it's going crazy. Are you watching a show?
me?
Oh yeah, I just hear something in the back.
Oh no, it's my girlfriend. She's like
Oh,
watching something in the other room.
oh noise. Um, that was like it sounds like your brother. But what we're gonna do is we're gonna have true, right? True means prime. So what we're gonna do is for 2 here, we're gonna mark this as false. And essentially what we're gonna do, this is I guess it's like a log of n solution because we're just gonna keep multiplying by 2, but we're gonna do this. For all the multiples of 2, we're gonna mark those as not 1, right? And then for 3, we're gonna do the same thing. So 3, and then we're gonna times it. We're gonna keep multiplying that by like by 3. So 3 and then 6. And essentially what it's gonna do is it's gonna generate a list of the prime numbers between that. And that solution is, since we're going to be operating n, but it's going to be n times like log of n, because it's going to be like exponential. We're going to be like exponentially finish it, something like that.
Okay.
So
Uh, I will say there's faster ways to do it, but I guess this works as well.
there's faster way to generate the prime.
Yeah. I mean, you could just. I mean, we could just go with this one because I mean, I don't think it really matters that much. But just in case you're curious, like there's a method. Like basically, you could just create a is prime function and just loop through all of the numbers up to the square root of n and see if it divides into them. And that's like O of n square root n. And you could just cache that function, or even you don't even have to cache that function necessarily. And then there's also like something called the sieve of Eratosthenes, which is like O of log n. But you can
I
just
feel like this
go
one
with
would
this.
be like only 2 is going to be log of 2n, right? But when we do 3, it's going to be log of 3n. When we do log of 4, it's gonna be it ends up
Yeah. Well, I'm saying it's
dividing
like O
down.
of log, like O of n log of n. So it's like the log of the log.
Hmm. Yeah.
But I mean, I don't think we can go over that another time. Probably. Yeah, just go with this. See if you can code it up.
See if I
I
can
think
code it
this will
up.
work.
All right. All right. Okay. So let me copy and paste my algorithm here. Yeah, I think all we need to also what we need to do is let's see. Let's do def solution. So we're gonna be given a left and a right here, right? So we're gonna be given primes. So let's just say def generate primes. So how do we generate primes? Well, we want to generate primes up until an n, and then so we'll do primes equals for I in range n. That'll produce, if it's 5, it'll produce 5 elements. Yeah. And everything's a prime essentially, right? Everything's a
All right.
prime. Or go ahead.
Yeah.
Everything's for I in range n. We return true. So now what we're gonna do is for I in range 2. I think you kind of hinted at is like you don't really need to go all the way up to n because pretend if I have 10, right? I don't really need
Yeah.
to. I don't like after 6. If I multiply anything, oh, if I go 6 times 2, it already goes over 12. I don't really need to look at that. So I kind of
Yeah.
just need to go like by n divided by 2 or something. Wait. Nah, because if it's 20, what if it's 50 or 100? Whatever. I don't need to optimize it right now. I think at some point we could just adjust the right boundary here.
Yeah, for sure.
Like n divided by 2 or something. But we're going to loop from 2 to n. And what we're going to do is for every single number, pretend we start at I. We're going to be like while current element. We'll do multiplier equals 1. While I times multiplier is less than, while I times multiplier is less than equal to n, what we're going to do is we're going to do primes times I minus 1 equals false. We'll do multiplier. So for example, for 2, we're going to do 2 times 1 is 2. Then we're going to, so we're going to do 2 times, like, it's 1 index, 0 index, so we have to do that. And while I times multiply is less than or equal to n, we just keep incrementing. And then that should generate us our primes if we do that for every single I.
Yeah, let's see if your primes function works.
And then we'll just return, like, we'll just do primes and then we'll do left to right plus 1. Because what we're going to do is like,
Oh, I see what you're doing. Yeah.
we're just going to, I have to fix these bounds because if they pass in 0, oh, we just have to do minus 1 because they're going to pass in like 1. So it starts here and then I think it's just this. So let's just print, let's just generate the primes for, I'll print this. Let's just generate the primes for 10 to 19.
Yeah.
And what the heck? I don't even care about that actually. Wait, where's this? Right, plus one. Yeah. N. Where's N? Um, let's just initialize N then. Um, dude, there's like some off by ones here. Oh wait, wait. All of them are false. Okay, wait. So if we N pretend N is 19, right? So we
Yeah.
want to generate 19 elements. So this is going to be 19 elements. And then we'll go from 2 to N. And then here we're gonna go to 19. So we need to do plus 1. So that'll include 2. It'll go for everything from 2 to 19.
Mm-hmm.
We're going to do I. So we're going to start at 2. We're going to start at 2, which is sorry. Yeah, we're going to start at 2 and we're going to start multiplying by 1. That equals N. And then we're going to okay, what's 2 times 1? 2 times 1 is 2. That's less than N. So we say that's false. Like the main problem here is everything is false. So we're not capturing the case. So we do need to do the divide. We do need to capture this bound properly. Right?
Yeah.
Otherwise we just like go through the whole list. So I think this will be, let's see what happens if we divide it by 2. Wait, okay, let's just do simple 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to generate all the primes between 1 to 9. That's essentially 1, 3, 1, 3, what else? 7, 9, right? Those are the primes, right? 1, 3, 7, 9, 1.
No. One's
Pardon?
not prime, 2 is.
2 is prime?
Yeah. And 1 is not.
1 is not prime?
No.
Yeah. I gotta go back to my math class. 4, 5. 5 is prime because it's only divisible by 5 in itself and 1, right?
Oh, yeah. Yeah, I didn't see you're missing 5. My bad. And 9
7.
is not prime.
Yeah, you're right. So, because it's divisible by 3. Okay, so if we have, let's just print out primes here. I'm gonna do like this. Holy crap. Okay, we print out the primes here. We're getting 1. Let's do it for 1 to 9. That should print us 1 to 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all of them are prime. You say 1 is not prime?
No. Also, you have 10, 9 here. I'm just going to put that as 1.
Where?
Well, like you had 10, 9 for
Okay.
generate primes. Just change it. I don't think it
So
matters right
prime
now, but just change it.
equals, this is false, right? So 2. 2 is a prime. Why is 2 a prime?
It's divisible by 1 and itself.
Yeah, 2 is divisible by 1 and itself. So can we actually do this? Do we do 2? Because if all of these are false, wait, I think I messed up my algorithm. If we instantiate all of these as true, is true, 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 Well, I think the first step is actually mark it false then. And then mark the rest as true. So this is going to be false. Or sorry, all of them are false. That means they're not prime. Okay. All of these are false. Holy.
I think you're going in the wrong direction here. I think you were going right direction first.
Well, like all of these are false prime, right? So
Yeah, but you don't want to instantiate them as that.
you don't want to instantiate them as false. Because what I was gonna say is, we're gonna, for one, we just do true, right? For two, we leave it. But for all multiples of two, we just. Oh, sorry. All of them should be true prime. Bro, I'm getting cooked. Okay, true. Okay, we start two, right? And instead, we just leave this as true, but we just start converting all the multiples as false.
Yeah.
And then we get to
Agree.
three. Three, we leave it as is, but then we just do all multiples. So it's 6, 9, false. 4 is the same thing. Well, it's already false, but anyways, we'll go 8 and we'll do false. 5 is the same thing. We like when we're at something, we don't turn it into false. That's the main thing. So we have to start the multiplier at 2.
Yeah, exactly.
So if I generate the primes, it's between this. Two, 3. What happened? Why is it 5 and 7? Wait. Whatever. I'm just gonna take it all the way to n. Wait. True, false. Okay, 1 is true.
I think it's because right here you're returning. You're looking at the wrong numbers.
You're right.
I think that's why you're confused a little bit.
The hell? Okay, we're going from 2. We're doing I. Okay. Let's just. Where's n? Okay, so 1, 2, 3. This should actually be prime. Why? How did it get to false? Because we went. Oh, what am I doing here? This.
Yeah, there you go.
Holy.
That should be right.
1, 2. And then we'll say for and we'll just do a filter here. And then we'll do a filter of x. We're gonna do a filter of like this. We're gonna be given our primes.
Okay.
But we're gonna
Going some Python. I like this.
We're gonna do lambda x. X is between x is greater than or equal to the left and x is less than. So we just want to keep all of the x's that are between those. If oh no, that's kind of dumb. What the heck did I do? I have to enumerate. Let me hit the enumerate. That was dumb. Tried to get fancy for no reason. Um, bro. Okay. What's the time? Oh shit, went over. What we're gonna do is for I.
Oh yeah, we did go over.
For I. What we're gonna do is yeah, I got cooked. For I in result equals enumerate the primes. What we're gonna do is like if result if the result and we don't care about one at all, right? Do we care about one?
No, we don't care about one.
So we're always gonna take the primes here and we're gonna go like that. If the result equals true, that means it is a prime. What we're gonna do is result dot append I plus 1, and then we're gonna return the result here. Wait. Oh, we already removed it. So we do. Oh no, this is cooked. 1, 2, 3, 5, and 7, and then we just remove the 1 here. Holy crap! Okay, we generate the primes. Now we have our solution here. For the solution here, we're gonna do primes in range. What we're gonna do is we're gonna call generate the primes of left and the right. That's gonna generate the primes between the left and right. So we're gonna calculate minimum distance, and then that's gonna be float infinity at first.
Yeah.
Say for I in range, length of primes in range minus 1. What we're gonna do is we're gonna compare adjacent elements. So we're gonna say min distance equals the min of min distance and primes in range of I plus 1 minus primes of range of just I here.
All right.
Then what we're gonna do is like for what are we gonna return? The first pair or negative
yeah,
1?
the first pair. Or minus 1, 1 if there's no min dist.
Negative 1, 1 here. So what we're gonna do is we're gonna do kind of the same thing here. For I in range like that. If we'll just say left, right. So just so we're not shadowing the last one. Right, variable names are just trash right now, but right element. Primes in range like that. If the right element minus the left element equals minimum distance. If the right element minus the left element, the distance between these is equal to that, we just literally return left element.
Yeah.
Right. Something like that. Got cooked. Let's see.
Hey, you were doing pretty good there for a second, and then you just got caught up trying to create the primes. You got like you started with the multiplier equal 1. I didn't want to like give you a hint too early, and then you like went crazy.
Multiplier equals 1.
Yeah, that was what really like cooked you is whenever you and because like you had it pretty much you were good to go until you did this. I
Wait, hold
think you.
on. Oh, left and right.
I think it's because you have this
Where?
like line 77 here. I think is what's cooked, or at least you could fix it with line 77.
Let's see. Let me just see what primes in range. What? Oh, okay, because it has to be like left.
I
Oh, oh, wait. Oh, wait.
I guess no, I guess it wouldn't be that though.
If
Yeah,
if
probably just figured it good.
if I is less than left or I is greater than right, continue.
Yeah,
719. What's the result?
it's 11:13, so I think you probably want to do res. Whoa, no, not
Oh,
res. I
plus
think
one,
yeah,
plus one right here, right?
yeah, +1, +1.
Oh, damn.
Usually people will like create as one indexed array, so they'll just add an extra element so you don't have to deal with all these off by one things.
God damn. I enumerate primes. I plus one.
I think it might be I -1 rather. I don't know.
I minus. Well, zero. When you look at
Nah.
zero, that's one.
Uh, is it?
So we do if the prime number or if the candidate number is less than or and sorry
Oh,
and
okay. Well, no, you don't want and.
wait
Because that'll
zero.
never continue.
Bro, what the? Oh,
Nah, it's
sure.
just gonna always continue.
Wait.
You had it right before with the or. I don't know what's
Wait,
causing
let
it
me
to.
print out the primes. Well, it's only printing out 13, 17, and 19. What's
Yeah, so
the.
it's skipping 11. And you're starting at 10 here. Uh, here, just print primes here. I was curious if it's like skipping 11 in here or if it's skipping like whenever it's creating. So, no, it has 11 as prime. See, uh,
Is it here? Prime number if.
prime num less than.
Does this include I right here? Wait. Did I.
Oh, no,
Let.
it's because you're doing this. It's because you're doing this now. You don't want to do this because
Oh, shoot.
that should work now. Yeah.
Oh, man. Got cooked. Generating primes, man.
Yeah, you're doing yeah, I think like easiest way to do this is instead of doing this, you just do true for range n +1. Uh and then you would just use you would just use the actual number. So you would have like index 1 = 1. That way you don't have to deal with all these off by one issues. Because
Yeah.
they were kind of cooking you everywhere.
Goddamn.
Uh there's also like faster way to do this. So in this algorithm here, if you do like I times multiplier,
I
so
times I.
effectively, huh?
I times I.
Yeah, so you start with the square of the number and you only go from that. Uh, it'll actually end up catching everything. And this is how you make it log n, is by you start with the square root and then you go up from there, or you start from the square of the number rather. It's also why I was confused why multiplier equals 1 wasn't working, because if you do it this way, you start with multiplier equals 1. You don't actually well, I guess you wouldn't actually do this. You wouldn't do multiplier. You do uh, primes of I times I plus I think it would be, in this case, I, or I times multiplier. And then you would start with multiplier equals 0 here. Just the way you have it coded. Usually what you do is you do like a for loop. So you would do for I, like j in range. I think it would be like I times I. And then you would go to n. Yeah, that works.
I see.
I think, right?
Damn. Yeah.
Yeah, so you'd start like with I times I, you'd go to n, and then for your increment, you would use I. So you would just go up by I each time, but you would only start with I squared, and it makes it faster. But like that doesn't really matter.
Yeah.
I think overall though, you did pretty good in terms of like knowing just generate the primes is probably your best bet. You just kind of got cooked by the way
The
you were
easy part,
generating the primes.
the
I
implementation,
think
just
like
the implementation.
honestly, if you just study the Civ of Erasthenes for like 20 minutes, it's pretty easy to memorize it. It's like pretty hard to forget in my opinion. And then you just always know it. And it's like pretty much anytime you want primes, you're just going to want to generate the primes. Like if you want the primes in a range, you just want to generate them all. It's probably faster than anything else you can do for like 95% of problems.
Damn.
So this is like the right approach. Just if you study the Civ and you memorize it, it's super easy to not forget. And then you probably would have gotten this question in like 10
Oh
minutes,
damn. Yeah.
realistically.
Like I'm pissed at myself. I could have got a good higher on that, and I failed it.
Yeah,
Just bad
you
implementation.
could have gotten a pretty strong higher there. But I mean, I guess they're not gonna ask you this type of question at like a Fang. But if you're like interviewing for quant, I could see them asking something like this.
Telling you to generate primes.
Yeah, just like math stuff for elite codes. I
Nice.
feel like they would probably be more mathy.
Yeah.
Overall, I think you did pretty good. Like I said, you had the right idea. Just memorize it. Also, like, just I would just recommend doing this. This is so much easier
Yeah,
to
that
just
messed me up
use.
bad.
Yeah, you kept getting like everywhere you were getting cooked by this. Just like all not really here, but like up just everywhere in here you're getting cooked by I+1, I-1, just everything about it.
Yeah, and at some point I literally just snowballed. I couldn't even solve like very simple off by one.
Yeah, like after I think like you started at 2, like multiplier equals 1, and then you're like, oh, I don't know what to do here, and then you started like, oh, I'm just gonna like initialize these all as false.
Hmm.
And you're just everywhere after that.
Yeah,
Like made you lose your mojo.
yeah, but then you realize that you have to do it with multiple too.
Yeah,
All right,
because then or else you're just
everything will
turning
be
the whole
false.
array into true or false rather.
Nice. All right, thanks, Paul. Gonna
Yeah, no
take on the
problem.
next person. Yeah, let's do another one another time. Take on some even harder math questions if you got any.
Yeah, I got some harder ones lined up.
All right. All right. Peace out.
All right,
Thanks
peace
for
out.
running that.